I'm Viresh. Now I'm now I'm saying about a priority queue. So I and Srikanth are presenting a priority queue topics. Priority queue is a specialized data structure in which are similar to regular queue, but the major difference between the priority queue and the regular queue is that in the regular queue the elements are arranged in a flip-flop first in and first out order, but in priority queue the elements are prioritized based on their associated values. The characteristic of priority queue are as follows. Each element is characterized based on their priority value or basis. The element can added based on their priority queue. The if the multiple elements have the same priority, they are used to processed in the order they were added first in first out. The priority value can be any data type and its interruption depends on the specific problems or application. The this allows of specify this allows for flexible prioritization based on their various criteria. A priority queue must at least support of the following operations. It's empty. Check whether the priority check whether the queue has no elements. Insert with priority. Add an element to the queue with an associated priority. Pull highest priority value. Remove the element of the queue that has the highest priority and return it. This is also known as POP, element of get maximum elements or get front-most element. Some conventions reverse the prior, order of the priorities consider lower values to the higher priority. Some of this is also known as get minimum element and is often offered to as get minimum in the literature. This may instead be specified as separate peak at highest priority element and delete element function which can be combined to produce full highest priority element.
Hello guys, myself Shrikant and I am here to explain about the types of priority queues. As we have seen and heard from Viresh that what are the uh, applications that can be done on queues as well as priority queues and how they are arranged based on their order. Now we have two types of priority queues. One is ascending and the other one is descending. So moving on to ascending priority queues. Ascending priority queues are those in which the elements can be inserted in any order but only the smallest element can be deleted. As we can see in the table below, we have arranged the elements in ascending order itself. Even if we arrange it in random order, we will be removing the first element as the smallest element. That is, the smallest element will be the first one to be deleted. This is less common than the descending type. So here, the element with the lowest priority value will be given the highest importance and will be the first one to be removed. As in queues, the first element that is inserted will be the first one to be removed also. Here, the same thing, the element with which has the lowest priority or with the lowest priority value will be the first one to be removed. This means elements are processed in ascending order of their priority values, with lower values being served the first. This is how we represent the ascending priority queues. So before insertion of a new node, we here have the data as 10 and 20. We have two separate datas with the priority values assigned to each of them and the next address, that is the next node address. Next, we add a new node with data as 15 and priority as 4. Now, the new data becomes 10, 15 and 20 with the priority values 2, 4 and 5, and the addresses shall be assigned as 100, 600 and 200. As we can see here, even after the insertion of a new node, 10 will be the data that will be erased first because the priority value of 10 is least than compared to 15 and 20. Next, we move on to descending priority queues. Descending priority queues are those in which the elements can be inserted in any order but only the largest element can be deleted first. So this is the standard priority queue you usually encounter. Here we have arranged the elements as seen in the table in the descending order. So 50 will be the first element, that is the highest valued element will be the first one to be removed. The element with the highest priority value, that is here in this case we consider it as 50, will be given the highest importance and will be removed the first. As we can see here, we have values ranging from 1 to 9, such as 1, 2, 4, 5, 8, 9. We have 6 different values. The first value to be removed in case of ascending will be 1, whereas in case of decreasing priority order, that is descending order, we remove 9 as the first element. Coming on to applications of priority queues, where all we can use these priority queues are operating systems. Priority queues are used in operating systems for scheduling tasks, balancing the loads, as well as for handling interrupts. We can use this in real-time systems to ensure that high priority tasks are processed before low priority ones. And we can also use this in networking to prioritize important data, such as which is the most required data as well as the least required data, as well as the voice and video packets. We can use it in job schedulers to schedule jobs based on their priority, that is the highest priority jobs first, then the next, and so on. We also use this in data compression algorithms such as Huffman coding. Thank you.